Hey guys, today we're looking at 3.5 notes, which is all about graphing in slope-intercept form. So we start today with overhearing a nice little conversation between two different lines. You can see the one on the left here says, hey, my name's y equals 3x minus 1. What's your name? And so they're doing the right, just like, I don't know, slope dude. That doesn't really work for us. We want to try and make a more specific name for slope dude in this place, or in this case. So we know when we're talking about identifying people, we use names, right? They're always first name, last name, or some combination of additional identifiers. With lines, we know we use equations. Now, this equation right here, y equals mx plus b, is an equation that is called slope-intercept form. And we call it slope-intercept form because the two most important things about this equation that we see in our formula or in our equation is the slope of the line and the y-intercept of the line. So in here, we've got four different letters, y, m, x, and b. My x and my y values still mean the same thing. My x is still my input. My y is still my output for my equation. So I'm putting x values in, I'm getting y values back out. Now the other three things here, the other two things in my equation, my m is the variable, the letter we use to represent the slope of the line. So yesterday when we were going through and finding slope of those lines from 2 points or from our graph, m is the variable that we use just to represent my slope. And then b here, b is the y-intercept. Now, we haven't really talked about intercepts yet because we haven't done a whole lot of graphing. But remember, an intercept just means a point where my graph, my line, my function, whatever it is that I'm dealing with, crosses an axis. So a y-intercept would be where my line crosses the y-axis. So my x value is 0, the y value is my y-intercept, is that b value. So when we're going through and, like if we wanted to go through and try and identify the equation for slope dude, we have to look at what those two things are. We need to identify what's its y-intercept, so where does it cross the y-axis, and then what is its slope. So first off here, for slope dude, if this is my y-axis here that I'm highlighting in green, this right here is my y-axis, looking at where my graph crosses the y-axis at this point right here. This spot right here is where my line crosses the y-axis, which is up 2 from the origin. So in this case, that tells me that since it crosses at positive 2, my b value for this equation is 2. For my slope, we're going to do it just like we did yesterday. We're going to go ahead and pick out 2 points on my graph and then do my slope triangles to figure out what the slope is between those two. So here we can go down 1 and right 2 to see that my slope should be negative 1/2. So my m is negative 1 over 2. So if I wanted to put those two things together to write my equation for slope dude, to make the more specific name for that line, we would have y equals negative 1/2 x plus 2. X and y, when I'm writing my equation, will always be there. I'm going to do it exactly as it is. My x value, my y value will change to get those different points on my line. So all I have to do is replace b with my y-intercept and m with my slope. Okay, so let's take a look here on the back side. If we're just going to go through and identify from my equation what my slope and my y-intercept are, we're actually going to go ahead and skip this middle problem in here because this is like what we did yesterday. We're going to be, for today, for these sets of problems, we're going to be taking our equation and graphing it instead of necessarily going backwards. So here, for this first problem, my m is always attached to x, so my slope is 7. My b is this number that's always by itself. In this case, because it's a minus 3, negative 3 is that y-intercept. For the other one here, y equals negative 1/3 x plus 2. That tells me my slope is negative 1/3. My y-intercept is positive 2. So what we're going to be doing for most of these problems is starting with the equation and work on graphing those lines. That's what we're focused on today. So there's a couple of different ways you can do this. The order that I suggested going in is starting with your y-intercept, because that's a tangible point. You know from that single number right away that I have a point there. And then you can use your slope to make 1 or 2 more points on your line in order to get your straight line. So I'm going to start with plot the y-intercept. That's going to be step number 1. So for this first one here, y equals 4/3 x minus 8. This -8 is my y-intercept, so I'm going to go down here to -8 and just plot my point. Since my slope is 4/3, so here I'm going to use, for step 2, I'm going to use slope to create 1 or 2 more points. Now the way that I do that is kind of using slope triangles in reverse. So if my slope here is 4/3, 4/3, if 4 is my rise, that means I'm going up 4, and run is my run, or sorry, 3 is my run. That means, since they're both positive, I'm going up and to the right. So since that's my slope, I can go ahead and start at the point at -8, and I can just go up 1, 2, 3, 4, over 1, 2, 3, and this point right there is another point on my line, because I know it has to follow that same slope triangle. If we go back to that water slide activity on Monday that you guys were working on with Desmos, again, those equivalent ratios, we know that since my slope is 4/3, all of the points have to reduce to 4/3 for those equivalent ratios. So for a line, as long as you have 2 points, you're able to connect the dots and make a nice straight line. So if you want to stop here, you can. Just grab yourself a nice little ruler, line up the 2 points, go through the 2 of them as best you can, arrows on the end. So that's the last step there, which I didn't fill in. Step 3 is connect the points using a ruler, and make sure you don't forget the arrows on the ends. So that is going to be part of it. Neatness is an aspect of these problems. So finding your 2 points, usually these are about 3-point problems for most of these, where identifying your slope point correct, your y-intercept correctly is a point, identifying another point using your slope is another point, and then having nice straight lines with arrows on the end is that 3rd point. So we'll do a couple more just to get used to it. For this second one, my equation is y equals -2x plus 3. So I'm going to start with my y-intercept up 1, 2, 3. My slope here is a little bit tricky because it's just -2. But since it's not a fraction, we don't really have a rise or a run. We just have a single number. What we have to do here, if your slope is a whole number, we know that anytime we have a whole number, it can always be written as a fraction over 1. So that's going to be what we have to do here to utilize it. So here, -2 over 1 is my rise over my run. So now my -2 being my rise tells me I'm going down 2. And then my +1 tells me I'm going to the right 1. So from my y-intercept, I can go down 2 over 1. Down 2 over 1 if I wanted to continue. But again, as long as you've got those 2 points, you can grab your ruler, do your best to line it up nicely, and then connect your dots, going all the way to the edge of the graph paper, arrows on the ends. Okay, we'll do a couple more. I think 2 more, right? Yep, 2 more. All right. For this next one, y equals x plus 9. So my y-intercept is still pretty easy. +9 just tells me right up there at +9 is where my y-intercept is, where it crosses the x-axis. Now, I don't see a number in front of my x, but you just have to remember that means there's a +1 there. It's not a 0, otherwise my equation would disappear, my x would disappear. So since it's +1, if I wanted to make it into a fraction, 1 over 1 tells me I'm going up 1, right 1. And then that's my rise over my run. So you could go up 1 over 1 from that point. You may have some that end up being right at the grid line, where like you can't go, like if my slope here was 2 instead of 1, I couldn't go up 2 and over 1 in my triangle, like to make my next point. So what you would have to do there is switch both signs. So here I can go up 1 and right 1, but I could also go down 1 and left 1. that would be saying like my slope would be -1 over -1, which would be down and left. That still reduces to the same slope of +1. So just something to be aware of if you get some of those, which eventually, somewhere down the line, we will see one of those. Not right now, but eventually, again, just something to be ready for if and when we see one later. So still connect my lines with a nice straight line, or with a ruler, connect them with the arrows on the ends. That is what my graph looks like for this second to last one. Okay, last one, y equals -2/5 x. This one a little bit tricky because I don't see a b value. I don't see something that's been added or subtracted from x. If I have something like this where I don't see that y-intercept, that means if I was going to try and force something to be there, like I had to write in my slope on the last one, if I don't see something added or subtracted, the thing that I could put in there would be saying it's adding or subtracting 0. So in this case, my y-intercept happens at 0, 0, at the origin. Now from here, your slope, you can do one of two ways. Since there's a negative out in front, that means one of those numbers is going to be negative. It can either be -2 over 5, or it can be 2 over -5. It does not matter which one you choose. You just need to make sure that only one of them is given that sign. Because this can either be down 2 and right 5, or it can be up 2 and left 5. So from there, again, we can just go ahead and plot those points. We go up 2, right 1, 2, 3, 4, 5. Sorry, up 2 and left 1, 2, 3, 4, 5. Down 2 and right 1, 2, 3, 4, 5. Either one of those gives us the same line. So I'll grab my ruler. I'll connect my dots with a nice crossed arrows on the end. All right, that is the last problem for today. Homework is down there at the bottom. It's page 142, 16 through 32, just the evens. 16 through 32, just the evens. As always, if you have any questions, concerns, thoughts, or ideas, hopes, or dreams, make sure you guys are reaching out to us and letting us know. Otherwise, have a fantastic day.